If you've been doing CNC routing for a while, then you have probably experienced breaking a router bit, or when you hit the start button, the machine just plunged right into the project you were working on, ruining it after you've gotten through half the carve. This happens to almost everybody who gets into CNC space. And I can tell you the reason why that happens is because you missed a step during the setup. As CNC creators, our focus is, let's get that project carved. That's the most important thing. But it's not the most important thing. The most important thing in your CNC project when you start to run it is that your setup is done properly, so your carve is going to turn out exactly as you want it to turn out. Because this even happens to me as a pro, I finally decided to solve this by coming up with a setup checklist. A checklist that actually takes you through all the steps that you have to do during the setup of your CNC project to ensure that it carves properly, you don't have any bit slip, you don't break your router bits, and you don't ruin a project because you forgot to set the XYZ 0 point. So in this video, what I'm going to do is show you what we do during a setup following this setup checklist. And because this checklist works so well for me, that I am going to give you a free copy of this, which I've linked down below in this video. And I'm making this video because it is so important to do your setup right. And I want to make sure you understand why these procedures are here, so that you understand that every little step is vital to ensure that your project turns out the way you want it to during your carve. So in this video, we are going to dive into working through this setup checklist, and I'm going to provide a link down below, like I said, so you can get this for free. So let's get into how to work through this checklist. Why is this such a big deal? Well, we don't want to break a router bit. We want that carve to come out right. We don't want to ruin a piece of wood, on and on and on. You know the frustration if you've been around this for a while and something went wrong. When it comes to your setup, there are 3 main components that you need to take into account during the setup to ensure everything is done properly. Those are the material itself, your router bits, and setting your XYZ. And then, of course, a couple final things that you want to pay attention to, like having your finger on the stop button before you hit the start button so that you can stop your router right away. One of the first things that we want to make sure of is that our material is matching what we have actually done in the design. So the whole thing we got to do here is check our material, make sure it's clamped down properly, make sure the design matches the material size, and that we understand where our X, Y, and Z 0 points are at. So we're going to walk through this based on a project that I'm about to carve, this welcome sign here that I have designed up. And the first thing on this checklist is to ensure that the material that I have designated for this project matches the material size that I have put into the design software. So we're going to go back and take a look at this. What we're doing is we're double checking everything first. I'm in the Vectric software, which is what I recommend, and I'm going to go into the job setup, and now we're going to take a look at the material size that I've set up. So I have 24 inches wide by 16 inches tall by 3/4 of an inch thick, or 0.75. So the very first thing I'm going to do on this checklist is, first of all, put on the top what this project is. It's welcome sign. And the first thing is material size matches the design size. So we're going to do a quick measure. And the material is 24 wide by 16 tall. And we're going to check the material thickness. Now, when you're checking material thickness, you want to use a set of calipers rather than a measuring tape, because you want to get a little more accurate. You want to make sure that your router bit is not going to plow deep into your spoil board, and that's why we use calipers. If you don't have calipers, then you can get a set off of IDC Woodcraft website. It's a very large display set of calipers, and these will give you a nice accurate measurement. You have to have calipers in your toolbox for this. So we're just going to do a depth gauge measure. And first of all, you always want to make sure your calipers are zeroed out, which it is. And then we'll do that depth gauge measure, and look at that. This material is not 3/4 of an inch thick. So I'm going to do a couple of checks and just see what all I've got, find the thickest part of it. And we are 0.65 here. So what I'm doing now, just by doing this, is I am finding the high point on the project material. 0.63. Now this is telling me a ton of information right off the bat, that I have a high point, and that high point is where I need to set my Z0 at so I don't carve into my spoil board. And that high point was up in this corner right here, so I'm making a mark right there. So we have now double checked the material size, but we know that it doesn't match what's in the design. So I got to modify the design for that material size and recalculate all my tool paths. So we're just going to go right back into it, and we're going to change the thickness to 0.65. I'm going to put in 0.654, so we're going to back that up and recalculate. And it says, warning, the tool will cut through the material. So here's the first thing. Now that I've done all the design work on this project at 0.75, all my tool paths are now set for 0.75. Now that I just reduced the whole thickness by a 0.1, that means all my tool paths are now wrong. So I have to go back in and correct all the tool paths. So we're going to take care of that right now, and then we're going to get back onto this checklist. Okay, so I checked off item number 1 off this list. The next item on this list is making sure the material is oriented on the machine according to the design. So I've got a 24 wide piece of material, 16 inches tall, and that's showing on the screen here. So what this is telling me, and what it's confirming for us, is how this piece of material here needs to be sitting on the router. Is it going to be like this, or is it going to be like that? And I know that it's like this because I've just double checked it on the software, and that means that this is going to be on the machine like this. This long side is along the x-axis, so now I can double check that. Now it comes into our clamping. We want to make sure we're clamped down, and the whole part about this is making sure that we are clamped down securely. This is the point where it gives you some thought on this project. Now I've carved this already before, and what this is doing is making sure that we have taken into account the cutout of this project. Do we need to use tape? Do we need to use clamps? Do we need to use both when we cut this out to keep the project secure? So in this case, we only need clamps because I have tabs in the project. So I am now going to put clamps on the project to hold it down, and then we'll continue. So on the checklist, I am using clamps only, and I'm checking that off on the checklist, but I'm also going to make sure that the project is nice and secure. So I'm giving it a lot of force, and I'm actually jiggling my table. So the project is held up and held on the table very tightly. So I'm going to confirm that. And what this has also done is given me some thought on where I'm placing my clamps based on where the tool is going to start, what corners it's going to start on. And that is something that we're going to be checking on later to make sure that we understand that start point. So now we know the project is secure. Now the next step is surfacing the project. Obviously, I can't surface a project, but on here is once we get the project set down, the material is surfaced just before we start the carve. So I have already surfaced this project, and then I put it back on. But if you are putting a piece of raw wood down, then you will definitely need to surface it. And you just want to make sure you're going to surface it. And this, again, gives you thought about your carve. If this is a really fine, detailed V-carve, then surfacing is really important. And we already know that this has a certain high spot on it that's about a 0.02 difference. And that can actually make a difference on a carve. This particular one, it won't. But at least this checklist gives me some room for thought on that. So the material surface just before starting the carve, this is one point where you just want to consider that. And then finally is the material thickness matches the design thickness. So I actually checked that up here, and we already found that the thickness was off. I already adjusted it in the program. So now we can double check that, but I'm going to confirm it. I mean, this is what the checklist is for. So we're going to go back into the job setup and make sure, again, that I've got the right thickness set up here. So this is what a checklist has done. What we have done, we've completed the material checks. And in this material check, we have confirmed the material. We've double-checked the material. We've checked the thickness based on the design. We know that the material is oriented on the machine as it's supposed to be oriented, and we paid attention to the clamping method and made sure that we've clamped it down appropriately. The next thing are the router bits. So we're going to now step into router bit checks. And what this gives you opportunity to do is make sure you've got the right router bits selected, they're in good shape, your collet has been cleaned, and the first router bit has been installed in the machine, and a couple other things which we'll get to. So we're just going to follow this checklist in order. All the bits gathered for this project. So all the bits I've got to use for this project is the ultra clean cutting 90-degree V-bit, a 1/4-inch down cutting end mill, and the 1/8-inch down cutting end mill. I have this collet here. This is a high precision collet that you may want to get if you're using the smaller adapter collets. This is much better. It's machined with much higher standards, so you may want to check that out. I'll put a link down in the description for this, along with a link where you can get this checklist for free. So I've got all bits gathered for the project. So I'm going to click the check complete. And now the bits are laid out in the order that they will be used. And I've got this little count up system here so I can actually list out what's first, what's second, what's third, what's fourth. And that forces me to go back into my design, my tool path designs, in which we're going to come over to the tool paths. I've got listed right here the name of the toolpath and the router bit that I'm using. So the first toolpath uses a down cutter 1/4. The next uses a down cutter 1/8. The next two uses the 90-degree V-bit, and the final one uses a down cutter 1/4. So I'm going to mark that into these boxes. I'm going to say DC 14. You can use whatever code you want so that you understand. A DC 1/8, a V90, and then DC 14. And so now the bits are laid out. I've got the first one there, the second one here, the third one here. I'm sorry, it's the first, see, there we go. That's why we have the checklist. First one, second one, third one, and then the fourth one. And I'm going to refer back to this for the various different operations that I do, because I got to come back to the DC 14. So each bit needs to get inspected. That's the next one we need to check off, because you want to make sure your bits are in good shape so that you can take a good close look at them, see if you see any chips. I like to roll them in my finger a little bit and kind of try to turn it while I'm rolling it my finger. And then just roll my finger down gently, because it is a sharp edge. We're feeling the edge of the bit and making sure the edge is still sharp. We're going to do that for all the bits. And just get a close look. You can see this one's been used, so it's got some buildup on it. And so I'm just going to check the cutting edges with my finger. I'm pretty comfortable with that. And we'll do that with the 1/8. Down cutter, do the same thing. And that feels good as well. So my bits have been inspected. Now the collet needs to be cleaned of sawdust. This is a big thing that many creators don't realize at first. Cleaning your collet, that's the part in your machine that is actually holding your router bit. As you're doing carves, sawdust will get up into the collet. And as you take bits in and out, that sawdust gets in between the bit and the collet itself. And then you clamp down on it. That sawdust, that little bit of sawdust that gets in between the router bit and the collet, actually acts like a ball bearing. And when you start to carve, what will happen is you will start getting something called bit slip. And what that means is, as the router bit is carving, it actually starts to slip out of the collet. And the carve starts to get deeper and deeper, and you usually don't notice that until it's too late. So every time you change your router bit, then you have to clean your collet. Every single time, not just the collet, but the collet nut as well. So giving it a good close look. You can use a toothbrush to get into it and clean that out. I don't see any sawdust in there. So we are going to check that off. that the collet has been cleaned. The next is the proper router bit has been selected for the specific G-code file. I'm running 4 different G-codes. I have 5 tool paths, but two of those tool paths are merged into one. So I need to load that G-code up into my control software in order to know exactly what that is. So I'm going to open up G-Sender, and we're going to just load it to make sure. So welcome, and there's toolpath number 1. That's the one I want. And it says, let's move that. It says DC14. That's what I want. So that's the one I need to load into the software. Now I've got it there. We're ready to go. I've got that loaded in. So I am going to double check that. Now, one of the things is when we're doing this, we're going to come back around here. When I go to the DC18, we're going to come back to the router bit check, and we're going to start running through this again. So I got the proper router bit selected for the specific G code, and which is the 1/4 inch. So I want to get the other ones out of my way. I'm going to set them to the side here for just a moment. And the proper G code program is loaded into the CNC control, which I just did. So we're going to do that. And the correct router bit is installed properly in the spindle. That's the 1/4 inch router bit. So basically, this is like a baby step type of list that's making sure I am following a bunch of steps. So you can see already that this is forcing us to slow down. It's kind of a pain in the ass to do this kind of thing, but this is what's going to prevent you from, or at least minimize mistakes that you just don't want to have in your car because you forgot to do something. This is covering everything. So we're going to install the 1/4 inch router bit in here, and this is where we want to pay attention. Now, this list says to install your router bit properly. So what is proper router bit installation? That's where this little thing comes in, this little sticker right here. There is a proper way to install your router bit, and there's not a proper way or a wrong way to install your router bit. First of all, you never want to butt your router bit all the way up inside the collet where it stops. That area up there can be cut incorrectly, like at an angle or something, and when you butt the router bit up in there, it can actually put a side stress and break the top of your bit. The next thing is the rule of thirds. When you are putting your router bit into the collet, you can just kind of divide your shank into 3 visually. There's the top third, the middle third, and the bottom third, and those thirds are based off what they call the flute washout. That's where the grinding tool actually leaves the router bit right there. And so from that point, you're dividing things into thirds. You always want to go up about 1/8 of an inch, and that would actually be the technical place where you start your third. Visually divide that into thirds and then refer to this table here. You want the first third to be exposed no more than the first third of your router bit. That's good. Then you can run your normal feeds and speeds. But some people like to try to get more length out of their router bit to get more depth. And so what they do is they actually pull that router bit further out of the collet. And what that does, that puts a lot more stress on the router bit. And that leads you to potential for breakage. So that if you have to bring that out to the second third of the bit, so you're grabbing to about half of the shank. Now you have to start slowing your feeds and speeds down on your router bit because you don't want to stress that bit. You'll break it. And then finally, don't hang your router bit way out like that in the first third, just like we've got on the table here. If you are doing that, you are setting yourself up to break your router bit. And router bits are expensive. You don't do it. I'm a CNC expert. I've been doing this stuff for years and years and years. So don't ever stick your router bit out like that. All right, so we're going to install this with the first third, in the first third. Slide that thing up in there somewhere. There we go. And I'm visually down at the bottom looking at that, what they call the flute washout. That's where the grinding tool leaves. I'm putting my finger just above that, about the first 1/8 of an inch, and that's going to be my stop point. And that's how you install a router bit, and that's the proper way to install a router bit. And then, of course, we want to make sure it's nice and tight. Okay, there we go. when you do this, you don't need to over tighten. You want to get it to a point where it doesn't move anymore, and just give it another little pull, and that router bit is ready to go. So now we have installed the router bit, and we've properly installed it based on this chart. If you don't have this, I'll put a link down below for you to download this chart. I suggest that you get it, or if you are a brand new customer at IDC Woodcraft, get your router bits from here. All first-time customers will have this in their package. This is so important, and I've never seen a router bit company actually provide this kind of information. At this point, we've worked through material settings and your router bit settings. It seems kind of silly at times that we're doing all these little micro steps to make sure your setup is right. But at the end of the day, we don't want a ruined carve. We want to make sure our carve turns out okay. So we just need to be sure that we can step back and follow a checklist like airline pilots do. This checklist is available to you for free. There's a link down below. We're going to keep going through this, but I just want to say this works. Use it, and it'll save you a lot of frustration, especially if you've been CNCing for a while. You know exactly what I'm talking about, what it's like to break a router bit right in the middle of the carve. So make sure you go down in the description of this video, click the link, get your free copy of this. Let's get back into this, and let's finish off setting our XYZ 0 points, which is the thing that most people forget. Let's go. So super handy reference table. The next thing we're going to do is the thing that most people forget, your start point checks. Even me as a pro, I have forgotten this so many times. Setting your X, Y, and Z 0. This is just, I don't know why we forget it, but we do. And when we hit the start button on the machine, the router bit isn't set properly. It goes somewhere else, dives right in the material, breaks the router bit. So this is a vital thing that most CNC creators have forgotten at one time or another. So the first thing is we know where the X, Y, Z points are in the design. And what that tells me is I got to go back to my design again and confirm where I have established my X, Y, Z 0 points. So we can go into the job setup. I got to switch over, but I can see my X and Y is the lower left corner here just by these axis lines. But where's my Z? Is the Z on top or on the bottom? So we're going to take a look. We're going to open up that job setup again, and my Z is set on the material surface right there. So that means now I know that this corner right here is my X and Y point right there, and the Z is the top of the material. But because I did accurate material checks with a set of calipers, and if you think you don't need a set, if you think you don't need a set of calipers, then think again, because this is going to help you out making sure you're doing things very accurately. CNC routers are very accurate machines, so you want to use the tools that are going to be as accurate as you want them to be for the caliber of the machine. I know my high point is over here, so I'm going to actually write that on the board, high point. And what that's telling me is I got to set my Z over here. Now, I know where the X, Y, and Z 0 positions are in the design. So I'm going to check that. Now, the corresponding XYZ reference points understood on the project material. So I've just checked that. I put my little X right here. I've got my high point right there. I can check that off. And now it is set the XY 0 points in the control. Now, you're going to notice I didn't say let's set the XYZ. That's because sometimes we will set X and Y separate from setting our Z. So I'm going to set the X and Y on this. You can do it two ways. You can do it with a probe, or you can eyeball it. In this case, I'm going to eyeball it. I'm going to just going to align the center of the router bit along this plane and that plane, and then we will set our Z. So I'm going to go ahead and take care of that right now. We'll be right back. Set the XY 0 points in the CNC control. I have now done that. I've done it manually. I brought the tool forward. I eyeballed it along this way, making sure my router bit is centered along this plane and this plane. And then I went into the control, and now my X and Y is now zeroed. So that's taken care of. And then we want to confirm XY points are set in the control. Now, this is something that's really important that I don't think I've ever seen anybody think about, but it happens from time to time. If I was using a probe to set this, the machine will run through its cycle touching the probe, but I have seen it where it actually did not take it in the control. If you look at this image here, this is a table that somebody made, an epoxy pour table that was about $3,000 is what he was charging for it. And you can see that surfacing bit that he used dove right into the table as it was going into position. He swore that he set the Z value on that, but the Z value didn't take. I've actually seen it happen once on my machine as well. So that's why we just go into the control and we double check after we set our 0 that it's reading 0 right here. So now we've confirmed that the XY 0 points are set in there. The machine's in position. I've got the zeros there. And then we're going to get on to setting the Z 0 point. Now, if you're using a three-point touch plate where it's doing the Z and the X and the Y at the same time, then you're processing through all this at the same time, because now these last two are making sure you're setting your Z. So this is divided because it's based on if you are doing things manually. So I'm going to come over to this corner and I'm going to use my Z probe to touch my part, my bit down over here. That's my high point. That's what I want to work with. So I'm going to take care of that. Then we're going to get on to the final steps of this setup checklist. So I'm about to set my Z value, put my probe in place, and I need to bring the Z down before I actually start the probe cycle. And this is something I just want to warn you, never ever adjust your Z with the probe plate underneath it. Just move the plate to the side and bring the Z value down, or the Z axis down to where you want it. We're good there. And now I'm going to start the probe cycle for the Z. I'm going to confirm that I'm doing Z in the software, touch it like it's supposed to, and then run the cycle. All right, and now finally, we're just going to double check, make sure the Z has set itself properly. So I've just done this step here. Z 0 point set in the CNC control. I did that with the touch plate. And finally, we're going to make sure that the Z 0 point registered in the CNC control. So the way we're going to do that is I'm going to move the router away from the material. And I'm visually going to look at that. So we're just going to move it back over there. And I'm going to tell the machine to go to Z0. And then we're going to eyeball it. And I'm comfortable with that. We have now completed our XY Z0 check. I'm looking in the control. Right here, it says Z. So now I've double checked this. So we've gone through a lot of stuff here. Lots of little steps. This is what I want to point out to you is these double checks we don't do when we're doing this kind of stuff. We just kind of run through the process, but these double checks are making sure that you are following procedure. All right, so this procedure is a vital part of your whole process, and setup procedure is the most important part of the process. So we've run through all this checklist. Now we have our final checks to do. And these final checks, for the most part, are just going to make sure that we did what we said that we did, and all these other checkpoints here. So one is the dust collection is properly hooked up. I'm not going to do that because I'm actually not going to create this project because I've already done it already. So, but if I'm not doing it, then I can't check that off. Now we're going to double check that the proper G-code is loaded in the control. There's another double check. So I'm doing this one. It's the so listed over here, number 1. So it's that part of the welcome. We're good with that, so I can check that off. I'm going to double check that the proper bit is installed. That says DC 14, and I'm confirming I have the down cutter 14 right there. So I'm going to check that off. And then the spoil board area is clear of loose items. And what that means is I need to get my touch plate off of here. I need to get my tape measure out of here. I need to get my checklist out of here. And all the other stuff that may be on the spoil board. We want everything clear. And one thing probably needs to be added to this list is make sure that you move the router over to the start point. But that's not on there, so I'm going to do that. The spoil board is clear. The next step is turn on the router. I've seen too many people do this, especially if you have a trim router like this on your machine where you have to manually turn it on. we forget from time to time. And like I said, I've done it. I've seen other people do it. So we literally want to turn the router on by using the router on switch. In this case, I know that my spindle is turned off. This is making me look at my spindle control, and there are no lights over here saying that the spindle is on. So now I need to turn the spindle on. And I have to wait for the lights to come up, and I have to go through the procedure to make sure that spindle is up and ready to go, which is, I have to push the go button on it. But in the meantime, I'm going to bring the router bit of the router over to this start point here. We're going to raise it up. Make sure I'm clear, visually make sure I'm clear, and then I can start moving the machine over. All right, now I can tell you I just did something wrong in this whole checklist. I started to do some other stuff when I didn't finish this one checkpoint. So I needed to stay with the spindle until I knew the spindle was turned on, ready to go. So my own fault. So I got the spindle ready to go. It's reading what it needs to read. So we're going to say we flipped on the router. If you have a trim router, then we set the speed on the router. If you have a spindle, then that's going to be set in your database in the Vectric software. That's going to be taken care of. But if you have a trim router, then you got to set the speed dial right there. So we're going to set the speed dial just so I can say that we did it. This is a 1/4 inch router bit. I know that that goes to 3. And if you don't know what to set your router bit at for the different spindle speeds, then you can always get the IDC Woodcraft phone app. It's a free app that you can get from Google Play Store or the Apple App Store. And the IDC Woodcraft app has all the feeds and speeds in there, and you can put in your specific router. So if we have the Makita trim router right there, which is what's right here, you can click that, and now we have the speed dial set at 1.5 for the specific bit that I chose. This has the feeds and speeds for you. For all the router bits that IDC Woodcraft has, and you can get your router bits right here, so you don't have to go searching on the computer for a router bit. I'll link this app down below in the description, or you can just go to your app store and search IDC Woodcraft, and it'll come up. You can download it. It's free to you. All right, so we turned our router on, and the speed dial has now been set. Now we turn our dust collector on, since I'm not using dust collector here because I'm not actually running it, but we'll pretend I hooked it up. I got my safety glasses on and getting my hearing protection on, the other personal safety stuff that you want, so you're going to get that put on. And once that's on, you can check that off. And then finally, most important, the very last item is being able to stop the machine before you hit that start button. So whenever I start a program, we are putting our finger on whatever stop button that will stop that machine from running. So my long mill here, I've got a pause button. That's the button I would use. And we got an e-stop right there, ready to go. That's what you do. You put your finger on the stop button, you check that off, and you're ready to rock and roll. You can mark down all checks complete and hit your start button. And when you switch router bits, you need to start over again from the second part of the checklist, router bit checks, because you're going on to the 1/8 inch router bit. So you need to make sure everything's checked. You need to make sure your Z is checked. That's the other reason why I've got that separated from X and Y, because we've already set our X, Y. We don't need to change that. We do need to change the Z. And then you go through all the rest of the checks. This checklist is available to you for free. I've got a link in the description for this. I suggest that you get it and use it all the time, because this saves you from problems that otherwise you're asking yourself to have by missing these different steps. So go down in the description, get this checklist, and make good projects. Get yourself set up so you have the least amount of problems in your carbs. I'm Garrett with IDC Woodcraft. Have a great day, better tomorrow. Get the checklist. idcwoodcraft.com